Here is a good tip for you. If you do exactly what we did, but you find something a little bit odd, for example, the objects in the game is moving too fast or too slow, maybe because of this. So if you just click this stack here, you will get the statistics of the game you are running right now, and it's constantly changing. It's sort of a dynamic changing statistics. And let me get my pen here. So yeah, so I just take a screenshot of the game, and then we can look at statistics because it's constantly changing. And right now I got a more than 700 FPS, which stands for frame per second. And I think if you're pretty familiar with game, you must be pretty familiar with this concept. And the FPS essentially is just frame per second, which means that if you got a FPS of 703, let's just use that, and in 1 second you will get this sort of frame, right? So essentially you can calculate the time that you're going to have if you just take one frame. Okay, so frame just like a picture. Okay, so picture 1 and picture 2, like there is old saying of a movie called a motion picture, right? Because the picture actually moves. So like you are just be shown this picture 1 and then quickly change that to picture 2. Okay, so if the time interval between the changing of a picture 1 and picture 2 is sort of the time that you change one frame. Okay, so that's basically how you calculate the time interval. And here comes to a problem. So for example, if you use a transform position using say vector 3, we will discuss that later. And say for example, if you want to forward, right, so you want to forward a vector 3 dot, and you want to go forward, and say you want to say 0.05 f, which means it's flat, and which means that it will just move this unit per frame, but the frame rate is constantly changing. So if you got a super fast computer, you might get 1000 frame FPS. So if you just move forward 0.05 unit, and the user that plays computer got a pretty high spec, and they move 1000 FPS, and so you will get to move say 50 units. But what about the user computer only got 100 FPS? So it will just get 5 units. So here comes the problem, because on the different condition, on different computer or phone or console, the frame rate is different, and the user will experience different. So the experience is not consistent. So you might get a pretty fast computer, and when you develop a certain game, and everything moves so smoothly. And what you just did, for example, if you go to the triangle and say, yeah, let's just go to this hit laser, and what you just fine-tuned number, for example, some degree, the 0.1, and some speed, is like a scale factor. And you sort of scale that, you sort of fine-tune that according to your computer's FPS. And remember, your computer's FPS is constantly changing. So right now, just drop that to 300 to 400 FPS. It's no longer 700 FPS approximately. So even though the computer that I'm using to develop the game is constantly changing. So the degree and speed scale factor is constantly changing as well. So for example, if I give this some degree and some speed, and I test it and it works this way, it may not work this way on your computer. So if you just do exactly what we taught in the tutorial, in the bootcamp, you may not run this way. You may get a slower laser, hit laser, or maybe get a pretty fast hit laser depending on your spec. So what are we going to do? Here comes the concept of a delta time. Delta, we sometimes use delta as a let me just clean everything. So delta time means that this is will adjust the frame rate. So for example, if your computer run 1000, my computer run 100 FPS, 1 second, if you just set 1 second, this object will move 5 units. It will just move 5 units regardless of the frame that you're experienced. Okay, so for example, you got a pretty fine tuning frame rate that you just show every frame pretty smoothly. So the user experience is that it is not stuck. Okay, so everything runs pretty smoothly because in 1 second, and you got hundreds of thousands of pictures that's they move pretty smoothly, rather than just for example, my computer is pretty bad, so I may just got 3 pictures moving. So the user experience, if the user using these say phone to play your pretty AAA computer game, and they will feel pretty stuck, but it's got job done. It still moved from place A to place B. For example, move from place A to place B, and the distance between that is 5 units. And this scenario also got you place A to place B and move 5 units, but it will just give you more frame, so every transition is done smoothly. That's basically the idea behind it. So yeah, enough of this. We are going to use it in our code. Let's just go back to say, because I already got a lot of script running on, so what I'm going to do is just apply that just on heat laser rather than everything. Your job is to just practice it and add it to every code that you've been written. So yeah, let's go to the heat laser logic, double click it, go to the rider, and it's pretty simple because the hard working people in Unity already done that. I don't think this is done by Unity. I think it's just a common library that you can use it on C#, and Copilot already know what I'm going to write. So if you multiply time delta time, this will render this player degree unaffected by the FPS of the computer or whatever device that being running. And of course, you can do the same with the player speed. And of course, if you save it, you will run into a little bit trouble because of course, don't forget to update the some degree. You can manually update, reset it. Okay, and if you run it and you try to get this working, and because I got pretty high FPS, and so this laser move pretty slow. So what I'm going to do is to adjust that degree and speed to a higher level, say 5 and maybe 1. Let's just set it this way, and still pretty slow. maybe 20. Okay. And some degree 20. Sorry. Speed. Right, this speed is pretty good. And the turning. Oh, the speed is pretty fast. It's pretty light. And the turning is a little bit slow. So what I'm going to do is got the degree, say 100. So this should do. Yeah, this is more like a laser. You even can see the trailing here. And move to the head. Yeah, good. So yeah, basically that's it. So as I said earlier, you need to remember this degree and speed once you fine tune it, because once you stop it, it will not save, and your code will still be the original code. So degree is 100, speed is 20. So let's go back to some degree and some speed. So degree is I just forgot about it. Let's just degree 100, speed 20. Degree 100, speed 20. And of course, you can add F at the end of it, but there's not necessary to do that. Not required to do that. But you can do that. You can add F, regardless of whether it's a fraction or not, or integer. You can do that. Let's rerun that. I think I need to reset it. Let me reset it. Okay, so it's manually updated. And then let's try that. So I get a pretty consistent experience whether the frame rate change. Okay. Move it to the head. Yeah, pretty good. So that's it.